Dr. Stephen Quayle. I'm a senior teaching fellow in the School of Engineering, where I teach a number of computer-aided design tools. I used to do research around a virtual design centre looking at virtual design tools in 3D virtual reality. So the project was with a company called Atkinson Vos, who design various attachments and other bits and pieces for off-road Unimog vehicle. Historically, their engineering capacity at the company was very small. In fact, it was a single person who was close to retirement. And although they were very capable in terms of what they were doing, a lot of it was in their head or on a chalk drawing on the garage floor. So we looked at this with the aim of introducing new design tools, not only in terms of their engineering capability, but also to investigate how they could be applied across the business in terms of the added value that it brings, having control of design data, making it readily available across all the users within the company.
We are an engineering and vehicle specialist. We're based in Bentham near Lancaster. So we do everything to do with Unimogs and 4x4 trucks, and recently we started to do more and more design engineering work.
I think the original contact was made through colleagues within the School of Engineering who knew that the project area was very well suited to my area of expertise, given the historical links that I'd had with other companies in the design and manufacturing using software. Okay, the interest from me really was I knew the transformational effect that a lot of the new modern computational tools could have on a small company. It's something that we'd done historically a number of years ago. But personally, in terms of value, I think it's important for academic staff to keep contact with industry, to make sure that we understand the constraints that they're facing within the commercial environment, which often we don't come across when we're isolated just in an academic school.
The academic support and the technical support from Lancaster University was really a key motivation in pursuing the KTP. You know, I knew that there would always be somebody there to ask for help when we needed it, and very quickly we formed a really good working relationship with the engineering department, and over the 3 or 4 years we've had a dozen or so student projects running with Lancaster University up to PhD level, and I've really enjoyed that process. It's been really good for us because it's helped us to get more reliable data, do testing, this sort of thing, and help to speed up some projects which we wanted to do. And from the other side, it's really nice to try and help young people, give them an interesting project, something with a commercial basis. And something which I'm particularly keen on is to show that you can have an interesting and fulfilling career in a small business.
My name's Laurie Kent. Now I did a knowledge transfer partnership working with Lancaster University and Atkinson Vos. So I did an undergrad degree at Harper Adams University studying automotive engineering off-highway, similar to agricultural engineering, but focused more on mobility for off-road vehicles. Okay, so I worked as an associate design engineer, and we had a number of projects to deliver over the course of my KCP, and that involved embedding CAD systems into the business to speed up the kind of development process for designing bespoke expedition vehicles and agricultural appliances for Mercedes Unimog.
There were a couple of major projects which the associate tackled as part of the KTP. So one of them was the design and CE marking of an agricultural pickup hitch for the then current generation of Unimog. That was a big thing for us because those vehicles weren't supplied with those hitches from the factory, and for the UK market they're very much in demand. and we wanted to make sure that our hitch was the best, and we wanted to verify that it was the best through testing and ultimately through CE marking, and we achieved that during the KTP, which we were very, very proud of. And that's helped us to sell more of those vehicles into the agricultural contracting industry in the UK. And the other thing which we were looking at was the bonding of a camper box to a steel subframe. So most bodies on trucks are attached with mechanical fasteners, and we wanted to move away from that and use bonding. So that is relatively innovative for the industry in which we operate, and especially innovative on an off-road vehicle, because when a vehicle is driving off-road, it's very different to a lorry driving on a tarmac road. So that work continues. You know, we're always looking to try and refine and optimize what we do and make it even better and even lighter, and looking at different adhesives that perform better. But we achieved a lot of valuable work during the KTP on that. And really that opened up an entirely new market for us. And really almost overnight we gained a great deal of credibility in that because of the engineering, the CAD and the testing which we were doing, as well as being nice people to work with.
I think the KTP really transformed the business so that they then had a full engineering function available to them in terms of design. So not only were they able to create manufacturing drawings appropriately using the software, but because the virtual model then existed within the computer, they were able to then manipulate it. They could do various forms of analysis. They could perform stress calculations, proof of concepts. They could show to customers the ideas before they had to then commit to any manufacturing. I think one of the things that we learnt about was associated to some adhesive bonding that we were doing and exploring within the KTP, where in an academic environment we typically just have the data sheets that we would base calculations on. We might do some simple experimental testing within a lab environment. However, once you get to understand the business needs and the industry, it's very clear that they have very different operating conditions, that they don't have a perfect laboratory, that they are a working premises, and they've got all the constraints around that we needed to ensure that we could operate appropriately within.
The knowledge transfer partnership was the perfect opportunity for me to expand on my existing skills from my undergrad degree whilst taking on additional responsibility, managing commercial projects, being involved with the development of new products from conception all the way through to delivery, working with real customers on real budgets. Every day at Atkinson Vos was different. The list of daily activities would be incredibly diverse. You'd often start the day kind of planning stuff out and then doing some like detailed design work, but then having the workshop and all the vehicles on site meant that you'd spend a lot of time actually physically being involved with the vehicles, installing systems, being able to measure stuff on site, and then that would really speed up the rate of design.
I believe the KTP was appropriate for this project because it meant that the company weren't taking on a fresh graduate engineer without any additional support beside them, that they had the academic partner beside them that helped in terms of guidance of that fresh graduate. From the academic context, we certainly gained in terms of an industry partner where we got a much better insight as to their needs and their requirements, really to perhaps reinforce some of the theory that we know is there, but perhaps we might forget when we're in a full academic sense. So one of the things that we do within engineering is we run a lot of industry-focused projects for our undergraduate students. Sourcing of these projects can be very time-consuming, and quite often making sure the expectations of the company and those of also of the School of Engineering are met can be quite challenging. Having a partner through the KTP such as Atkinson Vos has really streamlined that process, and we've been able to offer a number of undergraduate projects over the 3 or 4 years that the project ran for. And I'm very pleased to say from that we won an award based on the CAST component that started off initially as a student project. The student themselves actually then were employed by the company as a graduate engineer, and that's when it was then recognised for the Casting Federation Award.
With the design and engineering capability which came through the KTP, is a much more sustainable business with transferable skills. We find it easy to recruit graduate design engineers because they're interested in what we do, and that's a really nice thing to have clever people wanting to come and work here. It's a really, really great feeling. And in fact, 2 of our best design engineers who are working for us now came to us as a result of student projects through Lancaster University. You know, we met them through the projects and then later offered them a job when they graduated. So I'd strongly encourage any business that's grappling with a problem that is just out of reach or wanting to take a step in a new direction but without having that particular expertise, technical expertise, whatever in-house. I think the KTP is a really excellent way of getting that expertise with the safety net of the academic support.
I thoroughly enjoyed my time doing a KTP. I would recommend it to anybody.